We're good? Okay.
Just let me know. I'll introduce you.
Oh, sure. Robin, go ahead.
I think they're bizarre. We say corporates. Okay, we're going to go ahead and get started here then. Thank you for coming for our next talk. It's going to be done by Robin, and his theme is relying on more transparent, trustworthy sources for Arch Linux packages. So let's give him our undue attention.
Hello, everyone. Thanks for attending this talk. Today we're going to talk about the decision that we took at Arch Linux to rely on what we qualify as more transparent and trustworthy sources for our packages. This is basically our response to the supply chain attack that some Linux distributions suffered from recently. Before we dive into it, allow me to introduce myself. My name is Robin. I'm also known as Entiz on the internet. I am a Linux system and DevOps engineer by day and an open source contributor by night. I am primarily involved in Arch Linux in case it wasn't obvious yet. But I also contribute to reproducible builds and a bit to Alpine Linux as well. So let's start with a few definitions. First of all, what's a supply chain? Of course, supply chain is a very generic term that can apply to a lot of things. But I came up with a simple definition for the Linux packaging ecosystem, as this is what we're talking about right now. So the Linux packaging supply chain is composed of all the elements that are involved in building and delivering packages to users. Whether it is technical components such as our build script, etc., but also the infrastructure the package is built on, the infrastructure that is used to deliver the package to users, and more importantly, also the individuals included into this whole process. So what's a supply chain attack then? Well, a supply chain attack is when one or more of those components is compromised, leading in undesired and unexpected behavior and malicious code being introduced in otherwise trusted packages. Now, do we have protections against supply chain attack? Yes. Fortunately, we have some mechanism to prevent or at least detect such supply chain attack. But monitoring and securing the entire supply chain remains a challenge, specifically the very early part of the supply chain. But we're going to see that later. So let's go through a quick list of a few of the mechanisms that we have to protect ourselves against supply chain attacks. First of all, we have checksums. So when we download the source for a package, we generate a hash of the source, and then this hash is locked into our build script as the hash that we expect the next time we're going to download or use this source. So that ensures that the sources have not been alterned in between multiple downloads or rebuilds of the package. But unmatched checksum could indicate a supply chain attack, but it may also have different reasons. We have a few upstream that have this bad habits of recreating a release, like they say they made a typo in the man page, and instead of cutting a new 0.1 release, they will discreetly delete this one and recreate it. Please don't do that, guys. Or it can be GitHub that decides to change their algorithm in Git archive that will change every checksum of every GitHub tarball. That happened. They reverted it, but once that happened. And as I said, this is technically more of a locking mechanism rather than an actual integrity check. Once we generate the hash, we expect this to never change, and we lock the source that way. But it's not like it guarantees anything in the content of the source in the first place. Then we have reproducible builds. Reproducible builds defines that from the same source, with the same build option and the same build environment, anyone should be able to reproduce the same artifact bit for bit identical. Cool thing with reproducible builds is that it allows to independently verify the path from source to binary code, ensuring that no supply chain attack occurred in between. So for instance, I, as a package maintainer, I could technically inject a malicious patch into my package before delivering it to users. Of course, all of this is very theoretical, right? I will not do that. But I technically could. And reproducible builds is a way to verify that I did not abuse my position, because you could try to reproduce the package and you should arrive at the same exact result as the package I am delivering to you. And if you don't, then I may have to do something nasty. The other cool thing with reproducible builds is that it gives you a technical verification process. So you don't have to trust me as an individual. You don't have to put your trust in me. You can actually verify it yourself with a technical process, which is obviously more difficult to compromise than an individual. While it's always a desired outcome for a distribution, reproducible builds doesn't always cover the whole supply chain, though, so that's a bit of the limit of reproducible builds. Specifically the very early part, as I said, but I'm going to demonstrate that in a minute. And the last mechanism we can go over is cryptographical signatures with like open PGP keys, like new PG signatures. This acts as an additional integrity check by guaranteeing that an artifact has not been tampered with since it was signed. I think this is an important part here. So when you sign an artifact, if it gets tampered with, then the signature verification will fail. So this is an additional integrity check. And the other cool thing with signatures is that it allows for the authentication of an identity tied to the signer. So that's basically someone to blame if something bad happens. So that's cool to have someone that is somewhat responsible for whatever they are delivering. But said identity may or may not relate to an actual person. Like an artifact could be signed by an identity that relates to the release team, like Arch Linux release team, and you don't really know who that is, right? This is a team. So it will not always tie to an actual person, and it may or may not correlate with the creator of the artifact. The person that signed the artifact is not necessarily the person that created it in the first place. And there is no way to establish an actual connection between the creator of the artifact and the signature. We just assume that it's the case, but it may not be. Also, I'm not going to spend too much time on this, but realistically, signatures are only relevant if they are accompanied by a trust path. Basically, if you maintain a chain of trust between the different keys you trust. If there are multiple keys involved in signing artifact and you just blindly add new keys to your keyring, then you're doing it wrong. It basically defeats the purpose. You want to make sure that if you trust that key and a new key is involved, you have a path between the first key you trust and the second one, creating the chain of trust that I'm talking about. If you don't have this bridge, then it defeats the purpose and you might as well just not verify signature, basically. So all of this to say, we have mechanism. And yet, this happened. So just a quick context here. So XE is a library to compress archive, basically, and it was backdoored targeting SSH, which would theoretically allow any untrusted third party to access to your machine remotely. And this happened despite the upstream package source being locked behind checksum, being cryptographically signed as well, and despite the infected package being reproducible as well. So the three mechanisms I showed you were correctly applied here, and yet the package got backdoored. So how did that happen? Well, there are a few things to note here. First of all, the malicious code was introduced in the upstream source by one of the upstream maintainers themselves, which, as I said, is a bit difficult for us to verify because such early part of the supply chain are out of our control. It's very difficult for us as downstream or distributor to have some verification mechanism on the very upstream part. So this makes it very difficult for us to detect. And another thing that is important to note here is that part of the malicious code, actually the trigger for it, was obfuscated by only being present in the custom-made release tarball. So what I talk about as custom-made tarball is those distribution tarballs that are distributed as an extra artifact of the release, or the tarball that you download from upstream website. And a lot of packagers build their packages against that source. And yeah, it can be abused. This is what happened here. So if you looked at the raw sources in the Git repository, there was no trace of that trigger for the malicious code. But if you download that extra tarball, then the malicious code was there. So that implies that there are different types of sources that we can use for our packages. I'm going to name a few, not all of them. But the first obvious one is plain VCS object. So just check out of a Git commit or a Git tag, basically a clone of the repo. You also have auto-generated tarball by Git4, so that is the GitHub auto-generated tarball, or the GitLab one, or the Codebug one, whatever you use. And you have those infamous custom-made release tarball. Oh wow, jumped a bit too far here. Why do we need custom-made release tarball in the first place? Why do they exist? Well, they are generally easier and more straightforward to work with on the packaging point of view, because there are some upstream sources that are based on technologies that requires preliminary step before you're able to work with it on the packaging side. Now, if there are packagers in the room, I may raise some PTSD for you guys, but stuff like auto tools, Git submodules, translation file, man pages. So yeah, auto tools, for instance, needs this very opaque auto-gen bootstrap script stuff that you have to run before you're able to work with sources. Git submodules are used to pull third-party dependencies that you may or may not need, and you would need to do that before you're able to package your sources. Translation files may need to be generated, man pages as well. And usually what upstream does is that they gives you this custom-made tarball. Well, all of these things are already done, so you don't have to take care of that on your side. They are also historically signed more often than other source type, probably as a way for upstream to promote this type of sources against other types. But they are also very opaque by nature and more difficult and involved to audit as compared to a Git repo that is publicly readable. So in my opinion, historically we have put way too much trust on signature over other mechanism. Well, we'll come back to that later. And this is as opposed to quote-unquote transparent sources. So for us, this is like plain VCS objects, or just a checkout of a specific Git tag or specific commit, or assuming that you trust those platforms, we also decided that GitHub auto-generated tarball or GitLab auto-generated tarball are okay, given that we trust this platform. But you know, all our code is hosted on GitLab, so hopefully we trust GitLab. And those sources are publicly readable, easily accessible, and therefore generally more audited. There are way more pair of eyes on a Git repository rather than on the content of those custom-made tarball, right? It gives you this feeling of what you see is what you get. So this is an oversimplified image, but I usually like to see transparent sources as a transparent box where I can see the content without having to open that box. And the custom-made release tarball would be an opaque box. And the signature on top of the custom-made tarball would basically just be a sticker on it that says, "Trust me, it's fine." You know? And I don't want to trust you, actually. I don't want to trust an individual. So, and you kind of have to do that with like custom-made tarball. While transparent sources, I can just look at it and say, okay, this is what I'm going to get. Now, as I said, it may involve some eventual cost in terms of complexity into packaging, because stuff like AutoGen for auto tool, Git submodules, etc., those will be on our side. We will need to do that. But we now think that it is worth it is worth the effort, because distributing packages based on more transparent sources is generally a good move both for us and for our users. And as a matter of fact, you probably cannot see it clearly here, but as a matter of fact, this is the fix that we applied on the XE infected package, and the fix is mostly just to switch to Git sources rather than this custom-made tarball. And you can see that we had to, where is it? Here, we had to have this auto-gen step that we did not have to do beforehand thanks to the custom-made tarball. Now we just do it, and that's fine, honestly. And we have it's not like a bulletproof source, but at least it is more difficult to obfuscate malicious stuff in those sources. So this is what we conclude from that study. Basically, so there is a link here. You have a QR code at the end to get the slide, so you can follow the link. So the link is basically a package. I switched from custom-made tarball to Git tarball, and it implies 15 Git submodules dependencies. So the package went from this to this, basically, in terms of a build script. But it's still worth the effort, because even at the cost of more complexity, we now think that those quote-unquote transparent sources and more trustworthy sources should generally be considered a preferred source for our packages. Regarding cryptographical signatures, GPG signatures basically, we only think that they are really relevant if accompanied by a trust path. So basically maintaining a chain of trust. And if you are not able to maintain that chain of trust, you might as well drop key verification. And if a choice has to be made between the two, so if you have to choose between transparent source or opaque source but signed, we now think that transparent sources outweigh signatures. Of course, in an ideal world, we would have both, right? Both transparent sources and signed sources. So we encourage now our package maintainer to establish communication with upstream, basically telling us our expectation on that front. And it should be very easy to do. Basically, signing Git tags is just what we need. So we can base our package against your Git tags and have that signature as well. Maintaining a trust path for us should be very easy as well. It could be a signed commit. It could be a signed message. One thing that upstream usually does is having a maintainer.amd file into their repo, and you would have the key fingerprint of every key that are expected to sign releases, and just having signed commits each time you add a new key or remove a key from there is enough for us to have a chain of trust. So yeah, that should be an easy step for upstream to do, and we are now establishing communication with them to hopefully be in the ideal world of transparent sources and signed sources. There are a bit extra resources about all of what I just said. So you have the XE Arch Linux Security Advisory, which says again that part of the malicious code was obfuscated into the custom-made tarball, and that the fix was for us to switch to the Git tags instead. You have this RFC that I conjointly wrote with David Runge, which is another Arch Linux maintainer. And this is basically what I just said in that talk, but in a very, very long document with a lot of technical things. So if you want to get further on the subject, there's a link to that RFC. And you have also whatsource.org. That is a website that was created by KPCYRD. He is also an Arch Linux maintainer. And this website is very cool because you go to whatsource.org and then you type, for instance, bash, and it will show you what sources every major Linux distribution are basing their bash package on. So you can see that, for instance, Arch is basing its package against a custom-made tarball, and Fedora does it against the Git tag, etc. So that allows you to see what distribution are generally using for a package in terms of source. Few contacts information, antis@archlinux.org if you want to talk to me. I have a website as well. I am on the Fediverse. And QR code to get the slides if you want to follow the links. And that's about it.
Great, thank you.
Thank you. Yes?
Do you prefer a git tag over a git hash?
I mean,
Question.
oh yeah. So do we prefer git tag instead of git? What do you mean, git hash? We have both actually. Our package tooling is able to generate a SHA-256 hash for a VCS object, so a commit, a tag, etc. So we actually have both. Question? Yes?
Would it help if the step from the sources to Octogen and creating the tuple was reproducible?
Oh, of course that would. So question is, would it help if the steps from going from the raw sources to those custom-made tarball, basically, so Autogen, blah, 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 were reproducible or at least more transparent? Of course that would help. This is one thing we are trying to do with upstream and discussing with them is to give us the information on what's actually done from going to this source to the custom-made tarball. That allows us either to replicate it on our side, so we grab directly the transparent source, or even better, if it is reproducible, we could technically be based on the custom-made source, and with reproducible builds, it would be fine. Yeah, so that would definitely help, yes. Okay.
One comment on that. For Debian, it's always, there's the rule. You want to have the source code in the preferred form of modification, which means all the generated files are not preferred form, so we always want to have the transparent form table, or strip away the generated stuff and generate it on our own again.
I mean, that is obviously a good... I should repeat the question. So Debian does it differently. Basically, what they do is that they grab the tarball, remove the custom stuff, and redo the custom stuff themselves, basically?
Yes. So
Sort of?
Sort of. That's the expectation.
Okay, that's the expectation. Okay. That's also a lot of work. I'm not sure if we are willing to do this. I mean, Debian is volunteer-based as well, true, but yeah, of course that would work. But for this to work, we would also need to be like a policy-wise and everyone doing that, which is also a bit difficult for us to do.
But we have helpers. Like for auto tools, we have a helper that does the generation.
True. What could be good as well is just not using auto tool. That would be even better. Other questions? Yes?
In some extreme cases, you have like multi-language moderator, where to generate, I don't know, small Python package, you need CMake, you need Python, you maybe need some Java stuff. Would you say, is it always worth it? And sometimes upstream doesn't want to cooperate because it works for them.
That happens. Like question is, there are some upstream build systems that are complex to work around, and sometimes upstream doesn't really want to cooperate with us. How do we handle that? Well, we actually decided to not rely on PyPy tarball for Python packages, mostly because of the same issue. And some upstream would actually tell you that they only expect PyPy tarball to be built. Yes?
And if it's the PyPy tarball created by some GitHub or GitHub automation, is it more trustworthy or it says the same?
What if the steps to build this custom tarball are documented or inside the CI that we can audit? Of course, that's better, but it's also more work. Ideally, we should find a good middle ground that would work both for us and for them. So yes, that would work, and if we have to do that, we will do it. This is not about reducing our number of packages because upstream don't want to cooperate, right? We want to keep the same repository state that we have. But yeah, that would be okay, but not the most desirable, basically. Yes.
Is there a systematic way to check if upstream changed the Git history between releases?
We now have one. We did not have one before. Oh yeah, repeat the question. How do we do if upstream recreated a tag, basically? How can we identify that and eventually confront them on that front? Well, with websource.org, the website I said, websource.org is now registering every of the commit hash and commit ID of a tag. And if it changes, you can see it that way. and it also gather a list of files from the previous tag and the new one, so we can also compare the list. So this is, we're usually relying on whatsource.org, or if our build servers still have the old sources, then we can use that as well. Yes?
So the reproducible build, is it actually reproduced by people or automatic process? And if there is a confirmation, will there be some automatic detection?
So we do have a, yes. Are our packages reproduced by third-party people or just by us, basically? Actually, both. So we have a report of our reproducibility of packages. So we have about 90% of our packages in the repo that are reproducible, and this rebuilder is maintained by us, but on a different machine than the build machine. Okay, I think that will be the last question, right? And we also have like third-party users that run their rebuilder instance, and that also shows the result. So you can compare our result with also third-party result, and they are usually on par.
Excellent.
Right, I think that's it.
Thank you so much, Robin.
Thank you.